So today we have a very, very special Rubik's Cube video with a lot of maths in it, which is of course the best combination for somebody like me. So in previous Rubik's Cube videos, some people asked me, well, can you show me your Rubik's Cube collection? Well, here it is, at least most of it. There's another 10 cubes here on the table and maybe another 30 or 40 at home and in the car, whatever I'm playing with at the moment. But that's pretty much it. So for the experts of you, how many of those do you know? All right. Now, obviously, I've got a lot of favorites in here, but recently, one particular kind of cube made the top 10. And I'm pretty sure hardly anybody watching this video has seen this sort of cube. I hadn't seen it before, which is rare. I mean, I've pretty much seen everything.
Because as you can see, you've seen all kinds of cubes.
That's right. And so the way I hit on this was I was trying to get this Rubik's Cube into the Klein bottle, right? And so I figured out a way. I made up this cube, and here's one of those that I made up for this project. It's a 2x2 Rubik's Cube, which is held together by magnets. So this one has a steel core and super magnets embedded in the individual dies. And so the magnets attach to the steel core. In this way, it turns like a real 2x2x2. Now, obviously, once you've got something like this, and you're like me, then you really go out and try to find out everything there is about this sort of cubes, And I found a couple of really remarkable things. The first really remarkable thing is this patent. It's dating back to 1972 by Larry Nichols for a 2x2x2, which is actually magnet-based. And this predates Rubik's design.
Would you say maybe that's where they got the idea for the Rubik's Cube?
Probably not. But still, I mean, it's predates, so this is really the original Rubik's Cube in many ways, right? And actually, the design here is really, really amazing. We'll get to talk about this a little bit later. Now, the second amazing thing was somebody's actually selling these things. Well, not 2x2x2s, but 3x3x3s. And obviously, I found this website, so immediately ordered 3. And I just want to show you one of those things. They're absolutely beautiful. So they're made from dies, and just listen to how they turn. Right, so it clicks in place, right? Clicks in place. They're heavy. They're made from cubes. 27 dies, right? Fitted together nicely into a 3x3x3. Now, the internal structure, the way the magnets are placed, is different from the 2x2x2. So what you've got here is, again, super magnets. And if you've got like any two of those dies meeting, like face to face, there's one magnet in here, there's one magnet in here, and they attract each other. And the amazing thing here is, and what also makes it a really, really nice maths puzzle is, how do you place those magnets so that at all times during a shuffle, everybody attracts everybody else, okay? And that's the first thing I kind of want to talk about here. How do you figure out how to choose your polarities? Okay, so what I've just done is basically take this magnet cube, kind of stripped off one layer, and I show it to you like this, right? So you see, the faces that I'm just showing you, but I've also indicated like the ones on the sides, right? Because they're also going to have magnets in them. So the first thing we're going to do is we drill holes, okay? And the holes go in these places here, okay? Now we put our first magnet in, and the polarity there doesn't really matter, so we'll just put it in like there, okay? So it's in there. And so once this is in, that forces this one here to be red, right, so the other polarity. So it forces that one here to be red, okay? Now let's just focus on this edge piece here. Now for those of you who are playing with cubes, you can basically leave that whole layer here fixed and just kind of twist this thing around with legal moves. So what I'll do is I'll just twist this one. Okay, so I'll twist this edge piece. And then, well, at this point in time, the magnets still have to always attract each other. So it means that forces this one to be
red as well.
Red as well. What about that one?
Now it's blue.
That's blue. Okay, red and blue. So it's forced, right? Let's just twist this one back. Okay. Now I take this guy here, and now I leave all the corners fixed, and with legal moves kind of move this guy here in all other possible positions. So for example, I could put it here, which would make these two guys here red, which would force this one here to be blue, or I could put it right in front of this one here, which would face this one here blue. In fact, manipulating like this, you can see once you've made your first choice, all of those blues are forced. So you can't do it in any other way if you want to ensure that everything attracts at all times. Well, once those are blue, these ones are all red. So we also get these things here forced. And well, at this point in time, you actually have another choice. So you can't infer anything else at this stage. So let's just make this one here. We've got everything red in here, so let's just make this one red too. It's our choice. We could also make this one blue. Make it red. That forces this one to be
Blue.
Blue. Now move this thing around. And what we'll see is that this forces all of these. Okay, which is pretty neat. Now, what does that mean? What does that mean? Well, that means that with just making two choices for our polarities, we've basically, fixed everything. Everything's kind of predetermined, except for those middle magnets here, which are attaching to the core, which you can choose any way you want. But I mean, it's kind of suggested here. Let's just make them all blue. And then you've got this nice checkerboard pattern emerging. And once you've got that, you can start thinking, checkerboard pattern. We can actually checkerboard the whole 3 by 3 by 3. And so that's actually what we've done. So checkerboard the whole thing. And then, just make, all the blue dice that you see here have blue polarities sticking out, and all the red ones have red ones sticking out. And if you actually manipulate this thing, like we're going to do in a second, so we made one of these, you can see that the checkerboard pattern always turns into checkerboard pattern, and that means that the magnets will always attach to themselves. And obviously, you think, well, now we've got something nice like this. I want everything else, right? I want a 4 by 4, I want a 5 by 5, I want a 6 by 6. I want everything, right? So what I do? Well, I got in touch with Owen Lillywhite, the guy who runs magneticube.com, my newest best friend, and asking, can you build me a 5 by 5 based on this checkerboard pattern? Well, he just went away and did it. And he's waiting here to tell you about it, all right? So here's Owen Lillywhite from America talking to the Mathologer in Australia. You finished the thing?
I did.
You did? Wow. How long did it take?
9 hours.
9 hours, unbelievable. Yep. Glad I didn't do it. So you basically went through the night, right?
I did. It took a long, long time. Of course, your night is my day.
That's fine. Yeah, okay. Okay. So can we actually have a look at it?
Sure. This is it.
Wow.
It's large and heavy.
How heavy is it?
Just over a kilo.
Just over a kilo? And it turns well?
It turns good. Let me show you. There's one layer. I'll do 2 layers now.
Perfect. Well, I'm really, really looking forward to seeing this.
Yeah.
So can you actually tell me a little bit about what you're doing there? I mean, you've been around for a long time, right?
Yeah.
I just discovered you like 2 or 3 weeks ago. But you've been doing this for quite a while, right?
Yeah, I've been doing it for a little over 5 years now.
Okay. But mostly 3 by 3s, right?
Yeah, in fact, I hadn't ever attempted the 5 by 5 until you helped me with it, asked me about it.
Yeah, well, we got it going. And it seems, it was this theory yesterday, and was taking quite a big risk there. I mean, it's the magnets are, how many magnets are in there?
There's 600 magnets.
600 magnets. So you had to drill 600 holes and push them in individually and glue them in place?
Yep, so I had to drill 600 holes, get my little screwdriver, get the little magnet, push it, put glue in there, hold it in place 600 times.
600 times, and you didn't make any mistakes with the polarities?
I actually didn't. I was quite impressed. I didn't make a single mistake.
Not a single mistake. 600 attempts and all of, wow. You must have a lot of practice with this.
Yeah, I've been doing it for a while, and honestly, the checkerboard pattern, which, most of my cubes aren't like this. Most of them are solid colors, but the checkerboard pattern actually helped because it kept straight what polarity goes where. I don't know if you can.
Oh yeah. Yeah. Yeah, no, that's definitely the way to go, I think. Yeah, and I'm just so happy that it actually worked out. I mean, we didn't know whether it would work out at all, whether the thing would turn or anything.
Yeah, I actually started from the middle and worked my way out. So once I had the 3x3 made, I was able to turn that, and that gave me some confidence that the whole thing was going to work.
Otherwise, you would have just given up at that stage.
Definitely would have, because even though it seemed like I was about halfway done, that's only 27 dice, and this thing's 125. So
125, 600 magnets, 1 kilo, 9 hours. Okay, so you're going to do another one tonight?
not a chance.
All right, well, anyway, that's great. So can you just give it to me now?
Yeah, sure. Here you go. Take it.
Wow, there it is. So we invented a 5x5x5 magnet Rubik's Cube. We also invented instant teleportation from America to Australia. Anyway, so there was Owen Lillywhite from North Carolina. And well, that's his website. And he actually offered a special discount for anybody who wants to buy one of well, the 3x3s or anything else really from him. And so there's a voucher in the description. So now I've got my 5x5x5, and at least today, this is the largest in the whole wide world. I'm pretty much sure of it. Now, I'm really looking forward to playing with this one. You can do a lot of these with this that you can't do with an ordinary 5x5x5. So when you start out scrambling this one up, all the dice are aligned in the same way, like all 3s out facing this way, all 5s facing this way, and so on. Now you scramble it, you solve it with the usual algorithms. Well, what you've done then is you've solved the outside, but actually if you have a look at the inside, how cubes are aligned there, they will be all over the place. So I can look into this one at any stage, and I can actually inspect how the orientations are. And so it will be a real challenge to kind of come up with algorithms that solve this sort of thing here inside out. And that even happens at the 3x3 level. Although it appears to be solved outside, inside, the central faces might actually be kind of still oriented the wrong way. The central cubes might be oriented the wrong way. But you can inspect it and basically solve it. I mean, basically it's a picture cube. You actually need big hands to manipulate this one here, but it's a nice one. Okay. All right. Now, if you actually ever get one of those, what many people don't realize, I'm sure that most of the people who got one of those didn't realize it, they actually buy a lot of different cubes in one. And let me just show you what I mean by this, okay? So you can transform this cube into many other cubes and play with them. So you're probably all familiar with floppy cubes. Well, if you're not, I mean, first time you see it is a bit of a miracle that you can actually design something like this. Well, you've got something like this sitting right in the middle of your 3x3. Just strip out the middle layer, and you can see you can play this like a floppy cube. It's really, really nice.
So you can do that with all 3 layers?
You can do this with all 3 layers, but I mean, the reason why I use the middle layer is because you see there's these extra big magnets in there, and there are extra big magnets also here and there and there. So they're basically forming the cross in the middle of the cube. And they actually also enable things to move very, very smoothly. So the middle layer, works best as a floppy cube, but you can use the other layers, they just don't turn as well. Okay, second variation. So what I've done here is I've just taken out all the corner pieces, and what you get is this nice, big, huge cross. And you can play it like a cube. It's basically just playing the edges of the cube. Very nice puzzle. It's actually, the overall shape is the logo of the local maths association, which is very good for me. So another variation here, what I've done is I've taken out a 2x2x2 from this. And now you can just manipulate the remaining layers. And so that's basically a variation on bandaging a cube. So when you bandage a cube, you basically make this 2x2x2 that I've taken out here immobile, or you immobilize it by bandaging it. Here I've just taken it out, and then so whatever's left over, you can play with. Right? And of course, there's different sorts of bandaging that you can do like this with a magnet cube. Okay, and then one more variation. Now I'm actually going to focus on the 2 by 2 by 2 that I've just taken out. So you're going to just strip off some of the layers here until you're left off over with a 2 by 2 by 2. And now this is checkerboarded. So when you think about it, if I actually make a quarter turn, things will not fit together. And that's a problem with all even numbered cubes like this. So if you checkerboard it, those cubes will not be able to do quarter turns. But what they can do is half turns. So I can actually play this one as a half turn cube. Right? So I can make half turns and it will attach nicely. So you can scramble it with half turns and you can solve it with half turns. I mean, there's quite a few puzzles out there that are done like this. Maybe I'll just grab one. So some of you may have seen these sorts of puzzles here. So these sorts of puzzles. So they're kind of rectangular, and because they're rectangular, you can kind of only do half turns with them. But usually the cubical shaped ones, you can always do quarter turns. But with this one here, you can actually only do half turns. So it's a feature. But of course, what this means is that you can't use this similar sort of thing to actually design, proper 2 by 2 by 2s. And well, we wanted proper 2 by 2s too. So we actually went back to this guy who patented this 2 by 2 back in 1972. And we just had a really, really close look at it. And so basically, instead of having these ferromagnets embedded like that, we just replaced every south pole, every north pole here with a different supermagnet with that polarity kind of sticking out. So it's going to be 2 supermagnets in every face that has a magnet in it. Okay? And the result is this sort of distribution of magnets. If you're just stripping out one layer and I'll show it to you, that's what you see. And Owen built a couple, and you can also get it from him now. So that's how they turn. They actually turn very nicely. All right. And well, the latest thing is, which really just happened yesterday, is I came up with a way of doing a 4 by 4 by 4, and gave it to Owen. Went through the night, and luckily I didn't mess up anything. So it actually, so the polarity chasing, that's what I call this, figuring out how magnets stick together, worked out, and we now got a working 4 by 4 by 4 too. And that actually uses a combination of these 2 magnets per face and 1 magnet per face thing. And maybe challenge for you is, can you come up with a design of a 4 by 4? Can you do it? Maybe another challenge would be, can you tell me in how many different ways you can put the polarities in a 3 by 3? How many in a 5 by 5? Let's see whether some people come up with good answers there. All right. Now, this is actually only the beginning for me in terms of magnet cubes. Now I want to actually do other Rubik's cubes as magnet cubes. And if you watched last week's video, there was actually one cubical shaped thing in there that I kind of manipulated around, which has magnets in it. I just wonder how many of you actually noticed that you can play this thing as a Rubik's cube. Let's show you. So this was this cube. So if you turn it around, it's got all the colors, and it consists of pieces that all look like this, and they snap in place because they all got magnets embedded. And now what you can do is you can play it like a Rubik's Cube, like so. And I've actually never seen a Rubik's Cube turn like this because it kind of cuts through the middle, which is very hard to do with any mechanisms. So you can do this. And in fact, you can even play this one here as a Dino Cube, if you know what I mean. All right, anyway, so that was something very exciting. I hope you enjoyed this, and that's it for today.